Hello, my name is Jameson Smith, and I'm an undergraduate student here at the University of Kentucky studying mechanical engineering. I'm here today to give you information and a progress update of my research into electro-aerodynamic thrust. The purpose of my report is to collect information to determine the likelihood and possible applications of aircraft using this propulsion method. In very simple terms, how close is the world to the introduction of aircraft with no moving parts that move completely silently without the combustion or consumption of fossil fuels? The intended audience of my report are potential and future researchers working with Dr. Suzanne Smith here at the University of Kentucky in the USRC. The USRC primarily focuses on UAS, or unmanned aerial systems, namely the design, materials, integration, optimization, and automation of these systems. This audience was chosen specifically to showcase how elements outside the scope of the USRC can be integrated into current research projects. Now, a little bit of background information. What is electro-aerodynamic thrust? To put it simply, electro-aerodynamic thrust is the generation of electric fields which ionize molecules. These ionized molecules will collide with neutral air molecules. The collisions of these molecules together create what's called ionic wind. And this ionic wind is what pulls the aircraft through the air, producing the propulsion method. The most notable propulsion method utilizing electro-aerodynamic thrust is NASA's Deep Space One, which flew for over 16,000 hours over the course of 2 years. Now, NASA chose electro-aerodynamic thrust, or ionic thrust, for Deep Space One specifically because even though it creates a very small amount of thrust, it can do so for a very extended period of time. So in the vacuum of space, over this course of propulsion, the Deep Space One was able to accrue a much higher final velocity than other propulsion methods. Now, bringing this same theory into atmospheric conditions produces several complications, such as air resistance and gravity. A team of researchers at MIT have been working on an enhanced version of a prototype. They have used computer-generated software, parameterization, and design optimization to create like a functional model. Now, this model is great and it works on paper and in the computer programs, but it is impossible to replicate in real life. To overcome these shortcomings, the researchers had to construct their own version of a battery stack and a new high voltage power converter. Now, once they took these additions and integrated them into the prototype, they were able to perform some test flights at the Massachusetts Institute of Technology's Johnson Indoor Track Center. Now, this prototype doesn't have any way to produce like a takeoff or get into the air on its own, so a bungee system was used to initiate the flight. However, once it was in the air, it flew entirely on its own power. Through the electro-aerodynamic thrusters, it flew for a total distance of 55 meters, which doesn't seem like a lot, but was actually the total distance allowed inside this indoor facility, so from wall to wall. Now, there were some concerns that this was probably just like a very optimized glider and the thrusters didn't have too much to do with it actually. So they flew it with the thrusters deactivated and it only flew for a total distance of 10 meters. Now, to collect all this information, what I did was I analyzed the flight trajectories, thrust to power ratios, and the design specifications of the MIT research abstract. And then I compared it to similar studies done at other centers of excellence rated by the FAA, such as Auburn University and Embry-Riddle Aeronautical University. Now, my findings after conducting all this research were an unavoidable issue and obstacle, that electro-aerodynamic thrust is most likely not feasible in today's conditions. There were several issues that researchers were unable to overcome. The first one was keeping corona inception above zero while still generating an acceptable thrust-to-power ratio. The second was that the electrode configuration was creating too much viscous drag. The third, and another really big one, was that the area of thrust density was much weaker than traditional methods of propulsion. Now, all this spells doom for aircraft utilizing this propulsion method. However, looking at how far this field has progressed in only a short amount of time, it still paints a very pretty picture for the future of aircraft. Possible applications. In urban environments, noise and sound pollution is generated by private and commercial aircraft. So a silent aircraft would definitely reduce that volume down to a marginal number. Another possible application is high altitude information gathering, such as photography, topography, weather forecasting. Other design methods using like propellers, jet engines, sometimes at very high altitudes where the air is a little bit thinner, temperatures are a little bit colder, they seem to fail. So mechanically simpler design would definitely go a lot further as long as we can optimize it with new developments in the future. And I think those new developments will come at an accelerated rate as long as there is adequate focus and funding put into this project. Now, there still is some work to be done. For example, my next focus over the course of the next week or so is going to be to construct my own version of an aircraft utilizing this propulsion method. Much smaller scale. Hobbyists use this for very mechanically simple aircraft all the time. So I will construct that, do my own analysis through flight trajectories and the same information tracking that the MIT researchers did, and kind of compare it to how they worked it. To see if I come into similar obstacles. Obviously, mine's going to be a much smaller scale. But the overall conclusion at the current period of time is that this is unacceptable for unmanned aerial systems, and especially for manned flight. Right now, the thrust generated just cannot carry a useful load. Now, are there any questions or feedback based on the presentation?